Good morning, students. I'm Dr. Divya. I'm here teaching you. Today's topic is soil-borne pathogen and their impact on crop production. First, soil-borne pathogen. What is soil-borne pathogen? They are teeny organisms like bacteria, viruses, or fungi that infect plant roots, stem, and leaves, reduce plant growth and increase cost to the grower and potential damage to the environment. So after all, it lost the yield production. So soil is a reservoir of inoculums of these pathogens, the majority of which are widely distributed in agriculture soils. So soil-borne disease. So the diseases are that caused by these pathogens which survive in the soil and in residue on the soil surface are defined as soil-borne disease. So cause many destructive crop disease such as damping of, second root rots, and third collar rots, and fourth stem rot, and fifth wilt disease. So reduced plant growth, increased cost and significant economic loss to the growers and potential damage to the environment. Survival of the soil-borne pathogens. So soil inhabitants like survive in soil for relatively longer periods, and second one, soil invader survive in the soil for relatively shorter period. So these are the two type of the soil inhabitants and soil invaders, and then non-pathogenic and generally in the form of saprobes, that organism live on decaying organic matter, and in crop debris, in seed, and on alternate hosts including like weeds. So types of soil-borne pathogen. First, fungus. So it causes root rots, stem, collar, and crown rots. Third, wilt disease. Fourth, damping of disease. In bacteria, Irvinia, like soft rot, Rhizomonas, corky rot of lettuce, Streptomyces, potato scab, soft rot of sweet potato. In viruses, so stunting and yellowing and spotting of lower leaves. And fourth one is nematode. Nematode pathogen causes root rot of nematodes. So fungus disease, root rots. The root system is to begin to decay, including wilting, yellowing, stunting, dieback, and eventually death. Pathogen infects the plant's roots and block the uptake and flow of water and nutrients through the plant. For example, Slylendrocalidium, Pythium, Phytophthora, and Rhizoclinidia. Stem, collar, and crown rots affect the plant at ground level. Symptoms are similar to root rots, but since the rotting start above the soil line, it can be easier to detect early. For example, Phytophthora, Rhizoctonia, Sclerotinia, and Sclerotium. Wilt disease, it's cause wilting, chlorosis, the lack of chlorophyll, necrosis, decaying of tissues, premature leaf drop, and browning of the vascular system, causes dwarfing like stunting, cause wilting of the plant despite adequate water. For example, Fusarium oxysporum and Verticillium species. So fourth, damping of disease. So it's affect young seedlings, infect the plants at germinations and shortly after, causing sudden death. So for example, that pathogen are Pythium, Phytophthora, Rhizoctonia, and Sclerotium roelfsii. Erwinia, soft rot. So watery and soft decay of the tissues, change in color, and in case of a carrot, stem also rots and becomes mushy with its colorless. Root rot nematode, it causes stunt growth, yellowing leaves, thinning plants, and damage in patches and premature wilting. So impact of soil-borne pathogen on crop. Soil-borne pathogen is a very harmful for the crop production. Most of the soil-borne pathogen destroy the crop production, that they are reducing the yields and they cause economic loss, and they are responsible for severe stress plant can't survive. Some soil-borne pathogen is also beneficial for the crop production. Some nitrogen-fixing bacteria like Azotobacter, Rhizobium live in the plant root and they produce nodule and fixation nitrogen from the air. So this nitrogen is beneficial for the crop. So management of soil-borne pathogen. Growers first know that pathogens are present, where they are prevalent, and finally how much inoculums is in the soil. So first, soil-borne pathogen can be managed by in three ways. First, cultural control. Second, biological control. And third, chemical control. First, cultural control. So fertilizer application. Ammonium bicarbonate reduce the viability of sclerotia bodies of Sclerotium rolfici and Pythium and Phytophthora by application of phosphoric acid. Ripsium reduces the incidence of macrophomanian groundnut, providing good soil drainage and good air circulation among plants. Good soil drainage reduces the number and activity of certain oomycetes pathogen, like for example Pythium and nematodes. Flooding field for long period or dry fallowing may also reduce Fusarium, Sclerotium and nematodes. First we can do crop rotation. Rotation with legume and non-legume plants. Delays practices like deep logging of crop residue. Soil amendment like organic amendment like sawdust, straw, oil cake, and etc. Manage the disease like Pythium, Phytophthora, and Macrophomina. Soilization. Clear polythene is placed over most soil during sunny summer days. Increased soil temperature from solar heat. So second one is biological control. So in biological control, agents colonize the rhizosphere, the site requiring protection. Fluorescent pseudomonadids are the most frequently used bacteria for biological control and plant growth promotion. But Bacillus and Streptomyces species have also been commonly used. Third process is chemical control. So fumigation and soil drenching and seed treatment. Fungicides like prothiocarb and promocarb and metazylal are useful to control the soil-borne pathogens. Fungicides used for the soil treatments like including metazylal diazobane and pentachloronitrobenzene (PCNB) and capsan and chloronevab. These are the chemical control for soil-borne pathogen. So thank you.